Good evening, dear all. Here we are today with the CBSE 12th Standard Physics, chapter number 1, that is electric charges and fields. Now, basically, this chapter is under a unit called electrostatics. Electrostatics is a unit in which there are two chapters, chapter 1 and chapter 2 of the curriculum. Now, let us divide the word electrostatics into two parts. One is electro and another part is static. Electro is electrical charges. Static means the electrical charge is standing. Now, basically, we are here to understand this chapter by parts, and very importantly, we are here to connect the theory with the numerical. Theory has to be connected with the numerical, only then will you be able to solve the numericals. It's not numericals, numericals and numericals, which is a wrong notion according to many people or many students. Okay, so now let's begin with the chapter number 1, and topic of the textbook is joined together few topics, and a new unit I have created, and let's talk about it. That is methods of charging a body. Now basically this chapter is about electrical charges, so first we should know how to charge a body. Whether it is an insulator, whether it is a conductor, we should know how to charge a body. Another name of charging a body is electrifying the body. Electrification, electrified, these are the words which can be used in the question of the question paper. So let us talk about the methods of charging a body. There are three methods of charging a body. The first method is friction or rubbing, and the second method is biconduction, and the third method is induction. Now, for friction or rubbing, we can do this best for insulators. We can do the conduction method or use the conduction method for charging a conductor, and we can use the induction method for charging a conductor again. Okay, so we will consider each point one by one with few examples. We'll understand these three processes separately, and then we shall talk about few examples about each method. Okay, so first we are talking about friction or rubbing. Now, okay, so now we come to the topic friction or rubbing. That is the first method by which we can charge a object. Now basically we have to consider the process of friction in which two surfaces are rubbed. When two surfaces are rubbed, the charge which is available within the body comes to the surface, or it moves from one body to another body. Then you can say that the bodies are charged or the objects are charged. That is, surface come in contact and are rubbed. Then the charges are transformed from one body to the other. These two sentences together, we can say that we have put the charges on both the bodies. Body that loses the charge becomes positively charged, and the body that gains the charge becomes negatively charged. Clear? So we shall understand this process of frictional charging by few examples. Okay, so now let us start with the example, or let us quote some examples of charging by friction. Now, as you can see in the diagram, we can see two glass rods with positive charge here and positive charge here. They will definitely repel each other. Again, we can see a plastic rod with negative charge, another plastic rod with negative charge, and we can also see a glass rod with positive charge and a plastic rod with a negative charge. Now, these glass rod or plastic rod, they are insulators. So how did we charge these insulators? Basically, the frictional charges which we develop or deposit on an insulator is by friction, rubbing of surfaces. So here we take glass rod, rub it with wool, which is shown as some figure here. So glass rod, rub it with wool. Glass rod transfers charge, so it becomes positively charged, and wool gets the electrons, so it becomes negatively charged. Similarly, glass rod again rubbed with silk gets a positive charge, and the silk cloth gains the electrons which are negatively charged, so it gets a negative charge. Plastic rod gets a negative charge because it takes the electrons from the cat4, and this is positively charged, as you can see there. Again, glass rod here we have, so positively charged, and the plastic rod from here we can pick up will have negative charge. Otherwise, you can see that if one of the object is positive, the other will be negatively charged, because one object is transferring electrons to the other object. Rub the glass rod with a pith ball. Glass rod is positively charged here, so this will get negative charge. Plastic rod is negative charge, so pith ball will get a positive charge here. So you can see the various examples where the charge is being transferred or electrons are being transferred from one body to the other body only due to friction. Now, how can we get, or how do we understand that this has happened? Just by bringing these materials close to each other. If I bring a glass rod to the glass rod, it will repel as seen here. If I bring plastic rod to a plastic rod, they both will repel as seen here, negative and negative. Correct? Then if I bring a glass rod to a plastic rod, close to a plastic rod, they will attract each other. So now by these examples and by this schematic diagram, we can understand that if we rub two insulators, we can deposit amount of charge on both the insulators, but the polarity of these charges deposited on these insulators is opposite. That is, one of the insulator will get a positive charge, the other will definitely get a negative charge. So remember, due to friction, if we are charging two insulators, again and again I am using the word insulator because by this method we cannot charge a conductor. So if we are charging two insulators by the method of friction, charges will be deposited on both the bodies. One body will get a positive charge, the other body will definitely get a negative charge. This has to be put into your mind because this itself will be a concept which we are going to, or which we may use in the numericals. Okay, so whenever you are talking about any theory, you connect it to numerical. That is the best way of solving any numerical of any concept. Okay, so here we can see that some amount of charge, whether positive or negative, is deposited on the insulator. Okay, once after charging the insulator, why is the charge not moving? Reason, it is an insulator. We have applied frictional force such that the electron come to the surface of the glass rod or the wool, and or it can even transfer from the glass rod to the wool. But once it is deposited on the surface, the material of the insulator is such that it will not help the charge to move in any direction. It will just be deposited there. In simple day-to-day example, you take a plastic dry comb it with your dry hair, keep combing for some time and pick up that comb and try to attract a small piece of paper. That small piece of paper will definitely be attracted because of the charge deposited on the comb. So even try to relate whatever you are learning with your day-to-day life. That will be easier for you to understand the concept. So coming back to how to charge two insulators by friction, by rubbing. One body will get a positive charge, the other body will definitely get a negative charge. And once the charge is deposited on both the bodies, the charge will not move. The charge will be static. That's why we are talking about the concept electrostatics. Now we go to the second cut. Okay, now we go to the second method of depositing charge on a body. Now for conduction, we can use only a conductor. We can deposit a charge on conductor by the method of conduction. The word itself is telling conduction. Conduction means you are going to conduct the charge or you're going to keep the charge on a conductor. Okay, so for that we have charge is transferred from a charged object to a neutral object when the two objects touch each other. Now here the very important point which we are going to understand is that the body which is charged has to touch the other body. The charged object loses some of its charges and the neutral object gets the same charge. This word same is important. I'll come to that with that diagram. This method is used to transfer charge in a conductor. So what is the idea here is we have to take a charged object, touch it to a neutral object. The charged object will lose some amount of charge and the same charge will be gained by the neutral object. Then the neutral object is said to be charged. Example, here we have a electroscope, gold leaf electroscope, a simple electroscope which we can make in house with the help of a bottle. Both these electroscopes are boxed in a glass box and we have a metal rod, gold leaf which is attached at the end of the metal rod. So here we bring a charged body. We can use an ebonite rod. It can be an insulator. Here you can clearly see that we have touched a positively charged body. The same positive charge has transferred to the rod and the same positive charge has gone to the gold leaf which is attached to the end of the rod, and because both the gold leaves have attained the same positive charge will be transferred to the rod and then it will be there on the aluminium foil. Both of the leaves of aluminium foil will get the same charge and they will just separate from each other. So here we are charging the aluminium foil or the gold leaf by the method of conduction, that if at all you are charging a body by conduction method, same charge will be transferred. Some amount of same charge will be transferred to the another body. Charge can neither be created nor be destroyed. It can only be transferred from one body to the another body. This is the method of conduction. Now let us move to the third method of depositing charge on a body. Here also, in this method, we can charge a conductor only by this method. Okay? So let us talk about the process. Body is charged without touching. Which is a thing which has to be remembered, without touching. So we are not interested in touching the body. So go to the example. Here I have a negatively charged ebonite. I have placed it very close to a metal sphere. You can see that if this is negatively charged, the surface near to the ebonite rod will get a positive charge, opposite charge, because we are not touching these two bodies. Now we bring it to the ground. We touch the negatively charged portion of this metallic sphere to the ground connection. Those negative charges will go away into the ground, left over with only these positive charges. Once we remove the rod, we have removed the grounding, these charges are distributed. Why? Because this metal sphere is a conductor. Conductor has a property to allow the charges to move around or on the surface of the body once the charging is over. So they are uniformly distributed charges around the metal sphere. So in the process of induction by which we are charging a conductor, we do not touch the body. The uncharged body gets the opposite charge compared to the charged body which is brought close to it. It is used to charge a conductive material. So joining all the three processes of charging together, we can say by friction, we can charge insulators in which both the bodies get opposite charges, 1 plus, 1 minus. In the process of conduction, we have to touch the body. If this body is positively charged, this body also will get positively charged. In induction, we don't have to touch the body which is charged. If this is a charged body with negative charge, then this will be charged with a positive charge. We don't have to touch these two bodies. These are the key words which you have to remember for friction, conduction and induction. These are the three methods by which we can charge an insulator or we can charge a conductor. Okay, I hope I am clear with how to charge a body. Now, once the charge of the body is over, let us talk about the properties of the charge which we have deposited on an inductor, on a insulator or on a conductor. Let us talk about these properties. Property number 1, additive property of charges. Suppose I have deposited the charges Q1, Q2, Q3, Q4 n charges. Q1, Q2, Q3, Qn. These charges which are deposited on a surface may be positive, negative, positive, so on. So if I want to add these charges, I simply have to add them but I have to consider the negative or the positivity or the polarity of the charge also. So if I say that I am adding charges of plus 1 coulomb, coulomb is a unit of charge which we'll talk within another few minutes. Then I have minus 2 coulomb, then I have plus 3 coulomb, and I have plus 4 coulomb. So I simply have to add them by normal maths. That is plus 1 minus 2 plus 3 plus 4. What is my answer? Minus 1, 7 minus 1, 6. 6 coulombs is my answer, including the negative charge also. That is what is called as the additive property of charges. They are just added with their polarity as it is. Coming to the next property of the electric charge, charge is conserved. As I already mentioned, that charge is neither or neither created nor destroyed. It is only transferred. So in a system, the charge is conserved. What is the meaning of conserve? That the sum or the answer remains the same in a system. Now let us go to the third property of electric charge, that is quantization of charge. Now charge is always considered as an integral multiple of a unit. What is that unit? Just like measuring any other material, we have one unit, 1 kg, gram, meter. These are the units which we consider as a common unit for measuring any physical quantity. Like that, for considering the measurement of charge, we have a unit which is called as the charge of an electron, E. Value of this charge is 1.6 into 10 raised to minus 19 coulombs. So, according to the quantization of charge, we can write Q is the integral multiple of the charge E on an electron, where n is an integer, positive and negative. So this formula is called as quantization of charge, which is the first formula of your chapter. Q is equal to NE. If I substitute Q is equal to 1 coulomb, E is equal to, as I mentioned, 1.6 into 10 raised to minus 19 coulombs, I get N is equal to 6 into 10 raised to 18 number of electrons. What does that mean? That for one charge or 1 coulomb of charge, I have 6 into 10 raised to 18 number of electrons with the charge 1.6 into 10 raised to minus 19 coulombs on each of them. Together, they make 1 coulomb. Okay, so here we have learned the first formula of this chapter. Q is equal to NE. This answer you can just get by substituting these values and get the value of N. So I hope I am clear with what we have done up till now. For this particular portion, which will be put on your YouTube, and If you like it, please share, please subscribe, please like, please forward it to anybody who wants to learn or understand this subject in my way. Thank you so much.